Here's problem 3815. What approximately are the dimensions of the smallest object on Earth that astronauts can resolve by eye at a 200-kilometer height from the space shuttle? Assume a wavelength of 500 nanometer light and a pupil diameter equal to 0.005 meters. Also assume the eye fluid has an average index of refraction of 1.33. So, what do we know here? We're at a height of 200 kilometers, so that would be 2 times 10 to the 5 meters. And we're trying to distinguish a wavelength of 500 nanometers. Of course, we're going to have to worry about it being in the eye fluid. Index of refraction 1.33. And we have a diameter of our pupil aperture of 0.005 meters. In general, our angle of resolution, minimum angle of resolution, is going to equal, by the Rayleigh criteria, 1.22 lambda sub n over the diameter. This is actually 1.22 times the wavelength in a vacuum over the diameter times the index of refraction of the medium that's receiving this, in this case the eye fluid. And we would also recognize that if we're trying to distinguish between two objects that are some distance y apart at some distance L, that this angle theta for small angles is going to be equal to the tangent of theta, so theta is going to be approximately equal to y divided by L. So we have that 1.22 lambda over d times n is equal to y divided by L. Solve this for y, so y will equal 1.22 lambda times L over n times d. That's going to be 1.22 times the wavelength, 500 nanometers, times L, which is 2 times 10 to the 5 meters, over the index of refraction of the fluid in the eye, 1.33, and the diameter of the pupil, 0.005, 5 millimeters. So if I put all those numbers in, what do I get? 18.34 meters. So the smallest object that the astronauts can resolve by eye from the space shuttle at that distance, 200 kilometers, is 18.34 meters.